Have you ever wondered what the difference between you and the machine is, between your mind and software, and what would take to bridge that gap? Enter cognitive systems. Cognitive systems are a very interesting AI topic which will likely get much more public attention in the future. Hi, I'm Anna Maria Olteziano, and this is my series on AI topics. In this video, we will talk about cognitive systems or cognitive computing. Specifically, what are they? Why there even is such a topic. We will then look into how one can start implementing a cognitive system, what the process is, we'll check out some application fields, and we'll end by considering how a blueprint for a cognitive system may look like, or what are its parts. The topic of cognitive systems is interdisciplinary. It mixes AI, how artificial minds work, with cognitive psychology, how natural minds work. Other disciplines are also at times involved in the mix, like linguistics, philosophy, especially philosophy of mind, but also philosophy of knowledge and others, human-computer interaction, and neuroscience. Why do we have cognitive systems as a field? Why is it even interesting? Well, let's look at it from both sides, from the sides of cognitive science and from the side of artificial intelligence. Cognitive science occupies itself with the understanding of the human mind, or natural minds in general. However, machines are good at some things that humans are not good at. At what? Well, to take just the most obvious examples, machines can do mathematical calculations much faster, or they can perfectly preserve their memory, while people cannot do this. So, from the side of the human, it would be useful if machines could do those jobs for people, but then translate their result in something that is intuitive for humans. Artificial intelligence studies artificial minds, or how one could computationally implement a mind in general. However, humans are good at some things that computers don't excel at. At what? Most people, when they think about this, come up with creativity and emotion. But there are many other things at which humans are much better than machines. For example, solving problems without having all the information, or common sense knowledge. So, from the side of AI, looking at how natural minds work may inspire us to develop new methods. How would you go about implementing a cognitive system? Well, first you would pick the type of task you'd want your cognitive system to achieve, or the domain you would focus on. You could implement a system that focuses on tasks related to perception, memory, or reasoning. You could focus on problem solving, like Sudoku and Go, or even on creativity. My lab is currently focused on creative problem solving. You'd observe how humans or other types of organisms with natural minds solve the task, or just learn the psychological theories about how they solve it. Then, you'd think about the parts your cognitive system needs, and the processes you could use to implement such functionality. In the next phase, you'd implement the mechanisms you're interested in your cognitive system, trying to replicate the natural ability you're focused on, or some aspects of it. As soon as you have a working piece of software, you would then check to see if your artificial cognitive system now behaves more like a natural cognitive system. You could, for example, compare the performance of your system to human performance. You could analyze to see if designing these mechanisms offers advantages over existing AI methods or advantages in communicating and interfacing with humans. If this seems complex, it probably is. But don't worry, we will explore the various parts in a moment, and they will become clearer. Now, let's look at some domains in which you could implement your cognitive system, or parts your cognitive system could have. One of them is perception. Perceiving is defined as the ability to see, hear, or become aware of something through the senses. If you think like a cognitive systems developer, you would now ask yourself the question, how is human or natural perceiving different to data or sensory input in computer science? One example of what your brain does naturally when perceiving is the cocktail party effect. The cocktail party effect refers to the brain's ability to focus one's auditory attention on a particular stimulus while filtering out a range of other stimuli. For example, when you enter a crowded room with multiple conversations happening simultaneously, you can switch focus between the different streams and listen to which one you want. Now, being able to tune in and out of conversation at will is obviously not how a machine perceives the world, but you could try to make it do that. Another domain you could look into, which is connected to the previous issue of perception, is attention. Attention is the ability to detect and interpret sensory stimuli. Let's look at what your cognitive system can do. I will need you to focus on the screen for the next 5 seconds to check out how many green round shapes you can see. Ready? Okay, so how many green round shapes were they? If you answered 5, you are correct. And now for the punchline. Was there any yellow hexagon? Well, let's see. Apparently there wasn't, so if you guessed that, you're correct. However, you see how the second question is harder to answer, as you're paying attention to the green round shapes. How would a classical machine deal with this? First of all, it would not have such an easy time disambiguating between the green circles and everything else as you do. Our capacity for attention makes us able to see such things more easily. Nonetheless, this is to the detriment of observing anything else. Let's say, for one reason or another, in the domain in which you're implementing your software, the benefits of paying attention would massively outweigh the downsides of ignoring certain things. As a cognitive systems developer, you then ask yourself, how can you implement an artificial cognitive system that exhibits attention? And most importantly, what would trigger this attention? Speaking about attention, let's say you weren't paying any, and you lost your cat. You'd be now engaged in a search process to find it. What do you think would be different between how you search the world and a computer searches the world? Watch the second part of this video to find out. And make sure to subscribe if you want more videos like this.